To keep things tidy, I'll use an instantly invoked function expression. I will make a function called countUniqueValues. Its input will be a sorted array. Before I write code, I will write words. The first question I will answer for myself is, can I mutate the input? Yes will be the answer. For this, I will use a two-pointer approach. I will set up a left pointer. I will loop the input. Inside the loop, I will set up the right number. I will do nothing unless there is a mismatch between the left and the right. In which case, I will move left forward by 1. Still within the loop, if the right number is defined, I will update input's left index with it. Lastly, I will return the left pointer. Note that updating input's left index is where we'll be mutating the input. So for instance, calling the function with an assorted array, like this one, will return 3. That's because 1, 2, and 3 are unique values. I will write the code for setting up the left pointer. Count will be equal to my left pointer. Initially, I will use old school syntax to set up my loop. I will set up let variables for I and max. Max will equal the length of the sorted array. I will start out at 0 while I is less than max, increment I by 1. I will put the closure of the loop around my comments. I will set up writeNum to equal the current item's index plus 1. Only when the left and right numbers do not match will I do things. In which case, I will increment the left pointer by 1. Count is my left pointer. Only if my right number is not undefined. Not undefined because the value could be 0. In which case, I will update input's left index with the right number. Lastly, I will return count. It is my left pointer. I will set up a variable to capture the return of my function. I will use an arbitrary sorted array. I will log the output. I need to use parentheses in my function call. I need to change left to count in my code. Now I get expected return values. As a refactor, I will use modern syntax for looping the array. I will use for each. Num will be the current value and I will be the current index. I will copy the inside of the old loop as is and paste it into the new loop. It still functions as expected. I don't need these let variables anymore. I will set up a variable for the sorted array on the outside of my function. This will show the effects of mutation. I will pass in the variable. You will see that it looks different after running through the function. For clarity, I will decouple these console logs. Let's assume that I should not allow mutation on the input. I will need to set up my own internal reference to the array. I think that I should use splice like this. Let's see. That's not quite right. Let me double check something. Ah, that's right. It's slice, not splice. I always get the two mixed up. There, the input array is no longer mutated. I will remove my comments. They seem verbose at this point. Cool.